Question was why the water flow is so important, why there is always a water flow stated in the swimming pool heat pump nameplate, and why we pay so much attention to it when setting up the bypass valves. Because with the bypass valves, you can actually set up the amount of water that flows through the heat pump. You can increase it or decrease it. You can play with it. And why it is important. A swimming pool heat pump, unlike house heat pump, works on a relatively small difference between the water in and water out. So we talk about 1 degree, 2 degrees maximum. If you look at a standard house heat pump that works 5 degrees, 8 degrees, even more. If you look at the gas boiler, if you look at the solar, if you look at the electrical heater, all those systems work with much higher difference between in and out. So the heat pump efficiency, as you can see on this graph, this is actually, this is a 1500 black machine. This is exactly 1500 black behind me. So that is optimized for 4.4 cubic meters an hour. And as you can see by those 4.4 cubic meters an hour, it actually achieves the highest kilowatts in heating output. Means potentially it also achieves highest COP. In other words, at this point of 4.4, it will give you the cheapest heating for your pool. And how to set it up correctly? Well, first of all, on the old on-off pumps, you gotta turn the system on and wait from 5 to 10 minutes until the system stabilizes and really the pressures from compressors start to work at 100%. And then in the summer, you should set the bypass valves to achieve the difference between in and out of 1 to 2 degrees. In winter, it's less than 1 degree. Inverter heat pumps, it's a bit different because inverter heat pumps allow you to use different modes. So you need to first of all pay attention that you set the actual max mode or boost mode or whatever you might want to call it. Then you again wait the time between 7 to 10 minutes and you try to achieve 1 to 1.5 in summer, not more. Inverter heat pumps also have the decimals in temperature, so you can actually set it up more precisely. In winter, you're looking at a difference 0.5 to 1 degree. If you are hitting anywhere above 2 degrees in any given time, let's say 2.5, 3, etc., then your water flow is too low and you are hitting the left part of the graph. So your kilowatts and COP are decreasing. Again, if you are using anywhere below 0.5, I saw such installations where the flow was just massive, was 15 cubic meters an hour, 20 cubic meters an hour for a small heat pump. Then you are going to the right spectrum of the graph. Again, your kilowatts and COP are decreasing. So this is very important setup that you can make. Of course, the customer, unless the pump isn't really incorrectly selected, the customer isn't going to notice that the pump isn't working at 100% efficiency, probably after the energy bill comes in, but until that, he's not going to notice. This is something you will not get an alarm about, or you will not get any error message. This is something you just simply should know and apply during the installation or maintenance or service.